In question 13, part A is some very typical questions to ask you to use the vector theorem, and then in part B they give you a graph and it tests your understanding. Do you know the relation of this line and also the corresponding equations here? And then they ask you to express the area here. And then so let's start part A first. It's very easy one, so we just go through very quickly. They say that x minus 3 is a factor, so given x minus 3 is factor of x power 3 minus kx squared plus 45x minus 54, which if you let this one be fx, they try to tell you that f3 is 0, 0. If you put a suitable 3 to make the divisor become 0 and substitute into the function, then the result, that means the remainder, is 0. And then therefore, so something power 3 minus k something power 2 and then plus 45 something minus 54, and then it's equal to 0. And when we put 3 inside, so if we calculate 27 minus 9k plus 135 and minus 54, 9k is equal to 27 plus 135 minus 54. Divide both sides by 9, so k is 3, and then plus 5, 3, 15, and then minus 6. So k is equal to 12. So in part B, continue. In part B, there is a figure show a graph, and then B is a variable point here, and then A is the fits of the perpendicular from B to x-axis and y-axis. We let the point coordinate of A be B0. So we'll make it bigger first. They say that they let this point is B0. That means this is B. In other words, that means the distance between the original and point A is B. They try to use some not very direct method to tell you that the width of the rectangle is B. And then later on, they express the area of this rectangle. We need to find out the area of this rectangle. So to do this, the only information we have is about this equation. And this point, we consider point B. First, this equation means any point on this line, the xy will follow this relation. This is the constraint of any xy combination on this. So if this one, let's say if it is 5, then the corresponding y, that means the height, will be y equal to 5 squared minus 12 times 5 plus 45. So 25 minus 60 plus 45. So we will get 10. So I will find the corresponding height of this point is 10. 5 and 10. This is the constraint of the how it is related of this line and also this equation. So similar reason, at point B, x is equal to B, and then what is the corresponding y will equal to something square minus 12 something plus 45. I don't know what exact value, I just know it is in terms of B. So it is b squared minus 12b plus 45. It's totally fine because they say in terms of B, right? So that means the height here is something called b squared minus 12b plus 45. And to get the area, of course you use base times height, right? So you don't have to worry, you just simply say what you think. Area is equal to base times height is a little bit long. So it's b power 3 minus 12b squared plus 45. Even though it's not really explicitly related to part A, but you find x power 3, b power 3, negative 12b squared, negative kx squared. So k is 12, so this is consistent. 45, missing, it should be b. So 45b refer to 45x here. So it's quite similar, right? And then they give us 54 also. Are there 3 different points of B such that the area of rectangle is 54? So what they say is, given that the area is 54, how many possible cases, that means the roots, how many roots will fulfill this requirement, is what question asking. So in part B2, they're given when the area is equal to 54. So that means b power 3 minus 12b squared plus 45b equal to 54. And then this is a cubic polynomials. Only one method is make it become 0 and then try to factorize it. But how do I know how can we factorize it? No worry, your exam should give you enough hints. They at least will imply you there is one factor, or they just tell you directly. So if you still remember, we have one factor, which is x minus 3. But they say this is b. It's nonsense to write down x here, right? So you should say in this case is b minus 3. This is one of your factor. And then how can you find out the rest? Of course, you are going to use the long division to solve the problem. So 1 negative 12, 45, negative 54, b minus 3, so 1 negative. So we know the another factor is b squared minus 9b positive 18 equal to 0. And then continue just like usual zero product rule. And then b equal to 3, this is the first possibility. And then this one we may factorize it, minus 3 and then b minus 6 is equal to 0. b is equal to 3 or b is equal to 6. So we find that even though it's look like there are 3 roots, but basically this 2 is repeated. So we just count once, and then b equal to 3 or b equal to 6. In this situation, in this 2 situation, then the rectangle area will become 54. But we don't have the third possibility. So are there 3 different positions? Our answer is no. Only 2 different positions to fulfill the requirement.